Hi guys, I welcome you all for the course Manipulated Robotics. Today we are going to discuss inverse kinematics geometric method. In the previous class, we have discussed inverse kinematics for RR manipulator using algebraic method. Okay, so today we are going to see geometric method. So we all know that there are three methods. One is geometric method, algebraic method, and the numericals method. So in this lecture or in this course, we are going to see only two methods. One is algebraic method and geometric method. So it is for 2R manipulator. Okay. So let's see. Okay. So let me draw the manipulator first. So, so this is your first link, and then this is your second link. Okay. Then let's mark the angle. So this angle is theta 1 and then this angle is theta 2. Okay. Since it is a geometric method, we are going to add one geometry. Okay. So here I'm going to just project this. Okay. So that it is a right angle triangle. This length is L1, this length is L2. I mean link length, first link length L1, second link length L2. So from this we know that we know this L2 here theta 2. As per Pythagoras theorem, this one is L2 C2 and then this one is L2 S. You know this because this is a cosine angle. So cos theta is, so here I'll show you, cos theta 2 is equal to adjacent. So adjacent, let me put as a something, okay, adjacent divided by hypotenuse. So if you multiply this, this question mark is equal to LC2. Similarly, this is L2 S2. So this is one geometry we made, and we'll add one more geometry as well. I mean, just add these 2 points. Okay, so these 2 points, so that this will be O, and then this will be B, and then this will be C. Okay, then this point will be A. Okay, so OABC. So in this is theta 1, and then let's assume this angle is alpha. Okay, and then this angle is beta. Okay, so I think you have understood the geometry. So from this, we are going to write few things. Okay, so first let me see what is tan beta from this. Tan beta. Okay, what is tan beta? Opposite side by adjacent side. Okay, so this is tan beta, and then I'm going to draw one more geometry from here. So from here, okay, so this is tan beta, opposite side. This is opposite. This is opposite by adjacent. So opposite is, let me say y, okay, and then adjacent is x-axis because this is the, here only we have the gripper. In this gripper we have x, y, okay. So this point is y and this point is x. So we have given beta, okay. So now we have to give what is alpha, tan alpha. What is tan alpha? So here, see here, what is tan alpha? So tan alpha is opposite by adjacent. So what is opposite? L2 S2. L2 S2. And then what is adjacent? This one. So this distance is L1 and this distance is L2 S2. Very easy. So yes. Then L2 plus, so here this link is L1. Okay. So here L1 plus L2 C2. Okay. So this is my this. Okay, so now how will you get theta 1? So this is beta, this is alpha. So if I subtract beta minus alpha, I will get theta 1. So theta 1 equal to beta minus alpha. So let me take tan on both sides. So tan theta 1 equal to tan of beta minus alpha. So you all know this identity that the expansion is tan beta minus tan alpha divided by 1 plus tan beta tan alpha. Okay, so let's multiply that. Okay, so let me get this color. So now tan theta 1 equal to, so what is tan beta y minus x? Then what is tan alpha? L2 S2 divided by L1 plus L2 C2, okay, divided by 1 plus tan alpha is y minus x, and then tan beta is L2 S2 divided by L1 plus L2 C2, okay. So let's simplify this. So it will be, I mean, this we can cross multiply. So L1 plus L2 C2. This one is multiplied by y minus L2 S2 x. Okay. So let me name it this as a denominator. Okay, denominator is x into this. Then here also this is the denominator. So it is x into L1 plus L2 C2, and then here y into L2 S2 by denominator will get cancelled. So tan theta 1 equivalent to, so the answer is L1 plus L2 C2. This is multiplied by the known y value, L2 S2 by the x value, divided by 1, sorry, L1 plus L2 C2 x-axis plus L2 S2. So this is how we have to find out the theta 1 value from the geometry. Okay. Then let's do theta 2 now. So for that, let me recollect the picture. So the picture is, so here first link and the second link. And then the geometry we have added is this one. So this is theta 2, and then this is theta 1. This is L1 length L2. This one is L2 C2. This one is L2 S2. And here is your gripper. So this point is x comma y. Okay. Then this is O, A, B, and then this is your C. Okay. So now we are going to derive theta 2. So for that theta 2, I'm going to take this OB square. OB square. Okay. Where is OB? So here O and B. Okay. So if I take this OB means, so here this is my OB, and then I'm going to draw this line. This is already x, so this means this is x and y. So shall I write x square by, sorry, x square plus y square with this Pythagoras theorem? Okay. So this is x square plus y square. And also, this is also equivalent to OC square. Okay, so here this is my OB square. So this here also one more Pythagoras theorem we can make. Okay, what is that? OC square plus BC square. So this is also equivalent to OC square plus BC square. So what is OC square? OC square is L1 plus L2 C to the whole square. And then BC square is L2 S2 the whole square. Okay. So now let's equate x square plus y square is equivalent to, let's expand this. So L1 square plus L2 square C2 square plus 2 L1 L2 C2. L1 L2 C2. Okay, then here L2 square S2 square. Okay. So let's simplify this. So L1 square plus, when you combine these two, you will get L2 square, because C2 square plus S2 square is 1 plus 2L1 L2 C2. Okay. So we need theta 2. So C2 equal to x square plus y square minus L1 square minus L2 square divided by 2L1 L2. Okay. So what is theta 2? So theta 2 equal to cos inverse of x square plus y square minus L1 square minus L2 square divided by 2L1 L2. Okay, that's all. So using geometric method. So the geometric construction is, so this is my manipulator tool link. So I'm going to construct one more thing, that is the Pythagoras theorem. And then I'm going to draw one more line. That's it. With these two lines, we'll be able to find out the value for theta 1 and theta 2. So this is the geometric method. Thanks for watching.